Hey guys, my name is Jacob. I'm part of Route 28. We're at the plaza just right outside of University of Waterloo, and check out the part that we found.
So this is a steel diamond plate ramp. Its main purpose is to provide safe ingress and egress from the ramp. And although it has the name diamond in it, it's not actually made of diamond. It actually refers to its pattern, which provides grip.
So now let's talk about the features of the ramp. The ramp is comprised of 3 different metal steel plates that are welded on together. If you zoom out, you'll be able to see that it features 2 flanges that fix this ramp to the concrete building.
And unfortunately for this guy, it has corrosion here, here, and here.
And what's that called?
Uniform corrosion. And although it has uniform corrosion, you can see that some parts of the ramp has much more corrosion, such as up here, right under this lip on both sides, here, and along its weld here, and at the flange with flaking all around.
Now we're at the next door of business, and you can see that it uses the same exact ramp as the one beside it. Now, you can see that here the bolt has fallen off, and we can assume that corrosion was likely a huge contributor to it, just by looking at how corroded the piece is.
While going about our everyday lives, we notice that corrosion affects many different products that we use regularly. Some may be the rusty pair of shears in our garage or a rusty fork in our kitchen. One that our group commonly came across, especially while going in and out of shops, is the ramp. More specifically, our object is the diamond steel plate, and the reasons why we chose this item can be found in our supporting document. As Ivan said, the ramp's purpose is to create smooth transition at the threshold of an uneven storefront. The main stakeholders that benefit from this product are wheelchair users, people using trolleys, carts, the blind, and also the general population, as it decreases the likelihood of tripping and injury. Looking at what the ramp must accomplish, the functional requirements are that it must improve accessibility for building entrances with a difference in vertical levels relative to the outside ground. It must retain its strength and shape after prolonged exposure to applied loads and various environmental factors, and it must be able to support an average of 400 pounds, which is the average amongst most threshold ramps. Some of the non-functional requirements, or the things that don't affect the main function of the ramp, is that it should be physically appealing after prolonged use to benefit the business's image. Some of the constraints that we should abide by are that the ramp must adhere to ADA ramp specifications and that it must be corrosion resistant.
The intended operating environment for the ramp is open air outdoor. It is exposed to all 4 seasons of the year, along with all the types of high and low humidity weather and all types of precipitation. Additionally, it is located on a sidewalk near a parking lot, therefore it is exposed to high amounts of salt used to de-ice the ground in the winter.
From visual inspection of our ramp's features such as welds, severe uniform corrosion, and online resources like ramp manufacturer websites, we concluded the ramp is made of 1018 steel. This steel is categorized as a low-carbon steel containing 0.18% of carbon content and is typically dominated by ferrite and pearlite. 1018 steel is relatively low in cost and has excellent weldability compared to other carbon steels, making it suitable for a wide variety of fabrication processes. Additionally, it has a balance of toughness, strength, and malleability, making it a strong candidate for structural applications. However, a main weakness of this metal is that it is prone to corrosion due to low alloying content. The properties of 1018 steel align well with our ramp's features, which reinforces our assumption. Steel diamond plate ramps start off as a slab of steel, which is heated to around 900 degrees Celsius, known as the austenitizing temperature. It is then hot rolled, which is the process of sending the steel through a series of smooth rollers until it reaches the desired sheet thickness and pattern. After, it is slowly cooled down to room temperature, resulting in a ferrite and pearlite microstructure. The sheets are then cut to geometric shapes accordingly and welded together to create the ramp. Steel ramps can come with a special finishing process, and for our ramp, it appears that there may have been a coating, as observations indicate the presence of a black layer on the central portion of the ramp.
It's obvious that this ramp is not in its original manufactured state. There has been a significant amount of transformation shown by the discoloration of the ramp, and we suspect that this is due to corrosion. How did this corrosion occur? Why is there a color change? There are a few reasons for why the ramp is corroded. The first is simply uniform corrosion. The entire surface of the metal is attacked due to exposure to the elements, including rain, salt, and many more factors. This leads the material to thin and eventually fail prematurely. The color here is due to the iron oxide that forms from the corrosion reaction displayed on the screen. There's also a possibility for crevice corrosion, where corrosion occurs due to the stagnation of water. For this ramp, because of the unique geometry with a diamond shape, it leaves a lot of spots where water is unable to escape, and this leads to localized corrosion. There are a few reasons for why this corrosion is problematic. With a ramp that is susceptible to corrosion, the parts that come off or the iron oxide make it slippery. This slippery nature requires the ramp to have built-in grooves in the design to maximize grip when walking or rolling on the ramp. The iron oxide that comes off the ramp also leaves stains in the area, and it becomes difficult and inconvenient to clean. The corrosion present on the ramp reduces strength and toughness, leading to premature failure and an increased risk of injury. And lastly, it is not visually appealing for the building, and it may have negative effects on business prospects.
Steel is considered to be low in its environmental impact, largely due to its abundance in the Earth's crust and higher cyclability. The production of 1018 steel also generates 3 times less carbon dioxide than the same mass of aluminum. Because of mild steel's corrosive nature, it doesn't take long until the aforementioned problems surface, meaning its life cycle as a threshold ramp is rather short. This means that more resources are required to dispose and recycle the material at a higher rate. The IDMAT application shows that a similar ramp weighing 20 kilograms will generate about 94.14 kilograms of carbon dioxide emissions during its life cycle, with production, transportation from China, and disposal all taken into account.
A solution to combat corrosion is to use ferritic stainless steel. It is a viable alternative as it has similar, if not better, strength, hardness, and cracking resistance compared to 1018 steel. They are both primarily made of elements, iron and carbon. However, stainless steel consists of additional alloying elements, such as chromium. Alloying elements in steel result in high corrosion resistance. When chromium is added to steel, it forms chromium oxide, which acts as a protective surface to prevent air and moisture from causing corrosion. This makes it suitable for the outdoor environment that a threshold ramp is typically situated in. The downside of stainless steel is that the eco-cost values obtained from IDMAT are much higher than low-carbon steel. It is an expensive metal to produce and manage in its end-of-life cycle. Furthermore, it is more impactful to the environment as it produces more carbon dioxide. These calculated values are explained more in the supporting document. So, as a result, stainless steel is not the most feasible solution. A second solution would be to use a special finish, such as galvanizing steel, which can improve the sustainability of the ramp. The zinc layer acts as a barrier preventing oxygen and water from reaching the steel to form iron oxide. Galvanized steel will eventually rust. However, it is able to significantly increase steel's life, durability, and resistance to corrosion. Similarly, a coating such as a powder coat on steel can also prevent corrosion. Powder coating creates a durable, thick, hard finish, which prevents iron oxide from forming. More information regarding differences between powder coating and wet painting, including eco-friendliness, can be found in the supporting document. Unfortunately, this becomes problematic when a coated ramp is subjected to frequent momentary loads, which it will. These loads can wear any type of coating much faster, making it susceptible to corrosion. So although special finishing can extend the ramp's life without corrosion, it is not as beneficial in the long term. The accumulated cost and carbon dioxide emissions from maintenance will eventually be high.
Aluminum has a FCC microstructure. While this and aluminum's lower atomic mass explains its low density, the strength of pure aluminum is actually quite low compared to other metals. Aluminum 6061 can be and generally is heat treated, commonly through a process called precipitation hardening. This involves 2 stages, heat treating and aging. The alloy is heated up to and held at 525 degrees Celsius for roughly an hour, allowing the alloying elements to dissolve evenly throughout the aluminum solution. The alloy is then quenched not for the purpose of hardening, but to ensure that precipitates aren't formed during cooling. This stage is called a T4 temper and remains relatively low in strength. The metal then goes through thermal age hardening at roughly 200 degrees Celsius for 1 hour. Because the concentration of the alloying elements are higher than the equilibrium solubility, the solutes will diffuse to form clusters, assisted by vacancies within the aluminum lattice structure. These are called GP zones, short for Gunnnier-Preston, and are usually 1 to 2 atomic planes thick and range from 10 to 50 nanometers in length. As they are coherent with the aluminum structure, their mismatching radii cause strain in the surrounding lattice, which in turn opposes dislocation slips. This type of heat treatment and aging process is what gives aluminum its high strength-to-weight ratio, meaning less material mass is required for a given specification, increasing its sustainability. The metal is also strong enough that despite weighing considerably less than steel, aluminum threshold ramps found online were around 0.045 inches thick, which is very similar to its steel counterparts and could support up to 1,000 pounds, much more than the functional requirements. Most aluminum ramps are made by cold rolling and stamping. This is mainly due to its benefits of a higher surface quality, which reduces risk of localized corrosion, and more strength compared to hot-rolled counterparts. Although aluminum production generates roughly 2 to 3 times more carbon dioxide than the steels, its life cycle carbon footprint is considerably less at 34.17 kilograms of carbon dioxide emissions. A part of this can be attributed to its large domestic production in North America, which reduces transportation emissions, and aluminum being 100% recyclable, meaning that it retains all of its material properties one cycle after another. In conclusion, a combination of aluminum's lower cost, eco-cost, general sustainability, especially in recyclability, its natural corrosion resistance resulting in a longer life cycle are some of the reasons that we think a 6061 aluminum would be the best fit for this application. A decision-making chart is shown, which is a common and effective engineering ideation tool. It provides a summary of our justification for our final choice, with each metal being ranked on a number of criteria, 3 being the best and 1 being the worst. It can be seen that aluminum ranks the highest based on the results of our research, reinforcing our solution that it is the best material for this application.